All right, well, we might as well begin. So what I'm going to do today is I'm going to fix uh, just the project and file structure in KiCad, the hierarchy, just to make it flow properly. It's very similar to the hierarchy structure you can create in Altium. Uh, so we're just going to go ahead and use it. Well, I prefer to use just a flat hierarchy without, creating interdependencies. We might as well go and set up the KiCad project properly. So what we're going to do is we're going to Um, let's see here. Don't know if we have to close it. Let's see how KiCad reacts to having file names changed while it's opening. So we're gonna change this. We're gonna rename that to P10122025001 32. We're just gonna name it to cover sheet. Okay. And then what we're going to do is we're going to copy that and we're going to rename this guy to ESP32. Okay, so it looks like KiCad was okay with the changes we made. So we're going to go to the cover sheet. It's upset because I changed some things because it doesn't like the ESP32 sitting there. We're going to remove that. We're going to save it. So what we're going to do is we're going to change it to fix this. Okay, so the cover sheet's where we're going to put in all our stuff, but let's first draw in our hierarchy. Draw hierarchy sheets. Okay, it's going to be called power supplies. Boy, I can really spell. And we're going to have it go to the power supply. So we have let's dot KiCad underscore sch. Underscore dot KiCad underscore sch. That will be page number 2. Move this out of the way. Kind of put it over here. So that should create the link. Okay, so we need to create it. Okay, power supplies. All right, perfect. We're going to save it. So now it's got all right, did it show up here? Power supplies. There we go. Okay. Now we're getting somewhere with the with KiCad. So let's go back over to the cover sheet, clean this up. Oh, why did it say already open anyway? All right, come on. All right. Fascinating. Fascinating. Fix this up. Get this fixed up. All right, power supply. Drag you over. Go back here to root. Control X. Control V. Boom. All right. Now we'll go back to root. We're going to draw another sheet. Let's first make sure we know the name. Copy and paste. That way we can just copy and paste it in here when we get it. Yes, let's link it to that file. Save. ESP3. Haha, there we go. All right. Perfect. Now we've gotten that problem solved. The hierarchy over here is fixed. Pardon me. Didn't mute in time. So what we'll do is we'll use the cover sheet to store things like fiducials and any mechanical mounting hardware, any notes on. This will be just the root of our schematic. So we have our power supplies pretty much done. So we'll go over to our ESP32, pick up where we left off. So I'm going to use a 6.8 k ohm resistor, very similar to stars. Very similar to how I set up picks for the master clear pin, which pretty much does the same thing. It holds the device in reset until the power supply is stable. It's basically an RC timer network. All right, now look at thin film. So we're gonna look for 6.8 k ohms. 603. Let's not fancy ourselves and try anything too small. This isn't going to be a very small package or device. Plus, we have the top and bottom we can populate. We can 24 cents, 44 cents. Jesus Christ, many prices are just insane. 11 cents. There we go. Fichet. Okay. Oh, 10 cents. Panasonic. There we go. That's who we'll go with. And as usual, we need to set up our footprint library. Huh. That's interesting that that's the schematic symbol for a resistor now. Just weird. Alright. Weird. It's not the typical resistor symbol I'm used to using. So let's see if we can find. Alright. Let's go back to search results. We're going to open that in a new tab. Because I would like to find the classic resistor symbol to use. Let's see, does this guy use a classic? No. Maybe people stop using the classic resistor symbol. What in the world? The classic resistor symbol is gone. Wow. All right. That's something new. I never really noticed that change taking place, that people were stopping to use a classic resistor symbol. They're going to that for the resistor symbol. Okay. Okay. We'll go with it. Let's go to our downloads, extract all, blop. Go into KiCad. We will first set up the footprint. We're going to import. Hopefully the footprint's there. Okay. Hopefully. There we go. Open. Stop it. Okay, so we got that. Let's go to save it. We're going to resist 0603 components. Okay. Now we got it here. We can go to File, Properties, 3D Models. VRA, 3D. Oh, how cute. There we go. All right. Boom. Save it. Back to here. Our symbol editor. Now, since we've got a resistor, but we're going to follow some very similar things to capacitors. So what we're going to do is we're going to duplicate. No, we're going to need to import the symbol. So we'll just go ahead and do it this way. We'll just do it this way. All right. No, stop. Stop. So we're not going to show that. All right. So what we're going to do is we're going to rename this. So we're going to follow a very similar convention to the capacitors. We're going to RC resistor chip 0603. And then we're going to use 682, which is the resistor value code. 603, 682. We're going to look at the voltage because they do have max voltage level 75 volts 0.75. Now the other thing that we're going to need to do to devise a code for is the power rating, 100 milliwatts. So we're going to use a similar code. Actually, what we're going to do, let's see here. We're just going to give it AAA. That's going to be our 100 milliwatt. So before we get too far ahead of ourselves, let's go into parts naming conventions and we'll fix this. Again, we'll formalize this down the road once we get more here. Okay. Oh, here we go. Let's see. So for things like resistors and stuff, it's the same thing as like most typical chip capacitors. You're not buying mainly for brand, except for if you're looking for cost savings and things like that, or a favorite brand. Um, you're basically buying these parts based on specifications, their resistance, their package size, their power rating, uh, any other special things you want to note. Um, Anything special we can deal with down the road. Come up with a way to deal with it. If you have like a specific resistor that's the same value, but it's got more specifications, like something from maybe aerospace or medical. Um, uh, but for now, we'll just go. So typically, resistors are also uh, set up with the standard 3-digit value code. Sometimes they don't always use this, but we will deal with that later. Voltage 0.75, voltage, and AAA. Three letters for power rating. 100 milliwatt. All right, so we have that kind of formalized. That's going to be the product name. Let's go in here and let's go do something that, again, I made a mistake on. Let's get this. Again, maybe eventually I'll formalize this and make it a little easier. Just my little cheat sheet for going in here. Little properties. You know what? Instead of deleting that, well, I know I'm going to put it back in anyway. I'm just get rid of you. Footprint. All right, let's go. Our resistor 0603. Now, we're going to want to get the well, before I go too far, let's make sure we stay consistent with our naming. Yeah, okay. All right. We are. Resistor chip 6.8 k ohms, 75 volts, 0.1% tolerance. Sometimes, depending on your project, the temperature coefficient you'll care about. Let's go and put 0603 in here. Even though it's in the part number, the internal part number, it never hurts to have it in an additional place. 75 volts, 1%, negative 55 to 155. And then this also carries the ACQ200, which is the automotive rating. That is it dash 200. I just want to make sure. Nope, Q200. It's a special certification for parts that are better designated for automotive use. It has to do with the resistance to breaking and having physical failures based on the environment they're installed in. All right, so we have that. Okay, Rojas. All right, so we're gonna add manufacturer one. Make that a little bit bigger. What was it? Panasonic. Might as well copy that while we're in here. Part number. Oh, why put a space there? Mauser. So one of the reasons I'm keeping track of the costs in here is when we build up the bomb, uh, we could do some like rough estimating on how much it's going to cost to build like small batches of the boards versus large batches of the boards uh, for our internal use. Or if you've got a customer, it might help you better accurately quote um, a cost to build the boards. It's just something to be mindful of. It just kind of helps when with bomb preparation. So let's see, 10 cents and 0.043 cents. Put the part number here we just copied. All right, so we have our vendor 1A. So this is where you would decide for this specified resistor who you want to buy it. Who you want to actually supply it. Like the manufacturer, like Panasonic, Taiyo Yuden, Yagio, whoever. So that the bomb is where you do it. The part number, because there's so many manufacturers of these. I gotta fix that resistor. There we go. So before we close that, we're gonna go here to this guy. I know it's getting extremely fun, isn't it? This is the job. This is how it goes. That's the part number. It's good. Subtract inventory. You know. Again, we could use Odo to help track financial expenses and maybe set all this up properly, but that's not my goal. I, use external tools for that. All right, so we have to create a new category. We're going to create one. Resistors. Parent good. It's a good. Blah blah blah. Save. Reference is going to be the description. All right. Purchase. Mauser. Quantities of 1. Huh. Wonder why. Let's get rid of the lead time. Let's get vendor product code. Why in the world is that missing? Don't understand why that was missing. Don't really care about lead time. Vendor product code. Copy all of it. All right. Bam. We're going to save manually. So we go to our products. So I've got it set up to filter in the folders. That's why I create these different categories. It just makes it easier to organize inventory. That way you can just click on this, and it shows all the resistors that we have in our system, all the capacitors. And again, once you do get the part in once, you don't have to keep adding it every time. So that's going to be very helpful. So we're going to OK that. Since this stuff doesn't typically show up in the schematic editor, I'm not going to be moving it anymore. I'm just getting kind of old. So we're going to place a new resistor. RC. Alright. So, before we get too far ahead of ourselves, we can drag that and fix it later if we have to. Huh. It's weird. Why didn't it assign them? Oh. Okay. We might have to go through and see if there's a way to fix. Oh, annotate schematic. Okay. Oh. Oh. Okay. Okay. Close. So I bet you it saved it. Okay, they've got annotations. Okay. Perfect. 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 Okay. 104. No, come here. Ah. Okay. Let's drag these guys out of the way. No, stop. All right. You know, there's something I want to go and do before we get too far ahead of ourselves. Kind of, kind of clean things up a little bit. So let's go into our components. Start with a resistor. Properties. Let's add another value, another field here. Let's uncheck the show. Okay. Let's name it Val. We're gonna do it 6.8 k ohms. We're gonna call it show. Now let's see if it moved it over here. Is there a way to update? Update symbol. Update. Okay, I wanted it to hide. Did I? Yeah, I didn't want it to. I didn't want to show the value. I just want to. We'll see. Control S. Y. Let's try deleting that and re-adding it. Let's see if that fixes it. Yeah, I don't know why. Because we technically don't need the part number to show here. We want the value to show here. Oh, I don't want to have to go and delete these. Wait a minute. Why won't it let me move that? Oh, don't you dare do this to me. File, simple property. I should be able to move it. a pin. Get on my way. Can't put you there. Question is, will you stay when we stop? Eh. Oh, okay. I guess I can move it. I was being an idiot. Okay. Yeah. Okay. All right. All right. All right. That's just me being an idiot. Sorry about that. Like I said, I'm learning KiCad. We're doing the best we can. Let's go back up to here. These guys we'll leave alone. That is that guy. So let's go on to properties. Kind of fix these up here. We don't want to show that. We're going to add another field. Oop. Henry. 2.3 amps. Show it. Okay. That guy right there. Yeah, that'd really make for an interesting schematic of that pin just floating in La La Land, wouldn't it? Let's go and save that. Let's go to power supplies. Update symbol. Update. Close. Oh. Select all. Oh, I can fix it there. Oh, makes my life easier. Okay. A lot of times on the schematics, it's a lot easier to have the value rather than the part number. The part number means nothing to most people, but a value means a lot. So, yeah, it's tedious. We'll leave that alone since we don't have too many parts. We're just gonna go ahead and some properties. We're not going to show that by default, but we're going to. That is. Ah. F. And show that by default. Okay. Drop that there. Properties. We won't show that by default. Why I always do that? F. 1206. Show that by default. Okay. All right, and then we'll go up to here. Same thing. There I go again. Hit the wrong. Huh. Why aren't you showing it? Did I forgot to show? Okay. Back to the schematic. Update symbol. We're going to update all symbols. Oh. Alright. Oh. Okay. That made life a little easier. Okay. Just gotta do that up here. There we go. There we are. Beautiful. Beautiful. So we'll just make sure we add that valve field and accommodate any new parts, especially these type of parts. That make our lives a little bit easier in the long run. I could have it put the package size on resistors. Maybe I will. Who knows? Maybe we will. We'll see. Or I'll remove it from capacitors. It depends. But let's keep on moving. So we have our 3.3 volt line. We have our what we're going to do is we're going to make this a little easier. We're going to pop this kind of over here. And then we're also going to move this guy up over here. Okay, so let's see here. Oh, you don't like that. You don't like having. There we go. Okay. Now, our bus was style default. Can we actually assign a nut label? Not doing that. That's a port. Nut label. Label. We're going to call it ESPN. All right. Then we're going to all right. Minimal properties. Oh, hopefully this attaches itself. So in typical ECAD suites, like Circuit Studio, Altium, is you could assign a nut label to a wire like this, and by internally it will actually connect them when you go to put it on the board. That way you can reduce the complexity of your schematic, so you don't have wires going everywhere, traces, these wire drawings going everywhere. It's to make it. It's supposed to help simplify your schematics and make them a little cleaner and easier to read. Let's see here. Since these sheets aren't that big, I'm also going to global label. What is this? Let's see. Directive label. We don't need our directive. So I'm going to assume that'd be a port. Okay. So we'll. Okay, so it's an input. Let's see here. Technically, it'd be an input. Yep, that's a port. Now let's see if we can All right. All right. So typically, what ports are is they allow you to connect to a pin or a trace or a line on another complete sheet, on a completely different sheet than the one you're working on. As long as I put another port that matches this name to a T on another sheet, they'll be electrically connected. So then, when you transfer over to your PCB, they'll all be connected. The reason I'm doing this as a port is this sheet's not big enough. I think I'm just using a letter layout, which is perfectly fine. Maybe down the road we'll create an 11 by 17 layout sheet, template sheet for us, but for now we're just using the default that they gave us. So I'll have to put the UART bridge chip on another sheet, which isn't a big deal. So now I want to see about finding some 22 microfarad caps to also put in as a little bit of extra bulk capacitance on this guy. Let's go back over to here. Again, we are back to the wonderful thing of popping back and forth, finding parts, adding parts to our library, adding parts to our inventory control. I know it is the most fun thing anybody's ever seen. So we're going to SMT. Let's apply that. Maybe it'll clean up our choices here. Hey, what in the world did you just do? How in the world? I did not select a rating. SMT. What in the world? How is there only? Oh, Leo, how in the world did that get checked? An LCC. Oh, we don't want leaded. What no? Okay, what in the world is going on with you, Mauser? With LCCs. Boom. SMD. What in the world is going on with you? It's like the search is broken. Why in the world is that saying leaded? Packaging. What in the world are you doing? What in the world are you doing? Leaded. Axial radio. Okay, let's not go through here. Let's go here. Let's try this. Maybe it'll take us to the right page. There's something going on with that. Okay. 0603. Maybe that'll take us to the right. Okay. Oh yeah, that was weird. That was a glitch on Mauser's part. Something's weird. Oh, I want picofarad. I want UF. 22 UF. Apply filters. Okay. Well, we could go 6.3 should be sufficient. Let's see how many. 24 at 10 volts. Let's go 10 volt. All right, 32 cents, 48, 28, 31, 10 cents. Who is this? Murata. Okay. Got another good brand. 22 microfarad, 10 volts DC, 20%. 20% is fine for a bulk capacitor. It's not like we're doing extreme filters. Don't really need to worry about the symbol, model, and footprint because components. We have an 0603 capacitor that we can copy. We don't have to worry about footprint. All we have to do is get this detail 226. Alright, so what we're going to do is components. We're going to duplicate that. We're going to rename it. Alright, it's going to be 226. 10 volts. Its tolerance is 20%. And I think we only have 10%. So we're going to equals 20%. It's going to be AAB for 20%. B, and what is your dielectric? X5R should be fine enough, yeah, for our project X5R. X5R. Save it. File. Properties. Yeah, I just wish. 6. 10 volts. AAB, X5R. X5R. 0603. It's going to be 22 UF. Let's get in here. And it's going to be, what's the temperature range? 55 to 85. All right. It's Murata. That's their part number. Now we need the Mauser part number. And 10 cents. Wow. The brake only comes at a full reel, which is fine, I guess. I mean, 2 cents per at that. We'll go ahead and consider that the bulk price, high volume for now, because you don't. It doesn't look like you really get a price break anyway till you hit the 4,000 mark. So yeah, 10 cents and 023. All right. Okay. Before we save that, we're going to copy this. Lather, rinse, repeat. We're going to add this. All right. Category is good capacitors. Reference is going to be this. Okay, purchase is going to be Mauser. Product code is that. 1. There we go. Bam. Okay, now we're going to go back to KiCad. We're going to OK it. Save it. Back to our schematic. Drop in the new part. 603, 226. All right, so 2 of these little guys in there. Clean that up. this ground. Yeah, we'll put that there. All right. Huh. Okay. Interesting way of doing things, but that's fine. Drag you over. Here we go. All right. So that's our 3.3v3 or 3.3 volt input to the ESP32 with our filter and bulk capacitors. 10 UF. Let's see here. Maybe instead of the 10, let's go. That I probably grabbed the wrong one or duplicated 603, 104. Okay. Okay, so looks like I 104. Okay, that was me. That was me being dumb. All right. There we go. We're gonna update symbols, reference value, update reset, update all symbols, update close. So that should be 0.1 UO. Okay. All right. Didn't catch that sooner because I'm an idiot. Don't mind me. Don't mind the idiot. So what we're gonna do is we're gonna grab this. Stop. Drop this ground. Let's just go ahead and just. All right. Get these guys all tied together. All right. Now I think there's directives. That's what directive. No. Don't need a directive. So in Altium and Circuit Studio, there's no connect flags. This indicates to the system that they're not connected. These pins aren't used. Uh, so usually there's an electrical rule check that you can run inside the schematic that'll just run through and make sure all pins are connected. You don't have anything connected in weird ways. It can be useful. It can be helpful. Not always, but it can be. So what we're going to do is we're going to start kind of doing some of the plumbing for now. So we have our ESP32. We know that these are going to go to a UART pin on a different ESP. RX. And that is going to be an output. All right, I don't like putting those, like bunching those up like that. I'm going to put another one. Wait, no, that's actually an input. My mistake. All right, and we're going to put another one. ESPTX. That is the output. All right, because those will be on a separate sheet. Those ports will just connect over there. That's that's going to be mainly for programming. Now let's kind of figure out some of our plumbing based off of this, as we can start creating ports, because there'll be definitely on different sheets because we're just running out of room on this one sheet to hold everything, and that's fine. This is a perfectly an acceptable way to set up schematics. Uh, in my opinion, I actually prefer it because when you're troubleshooting schematics, the hardest thing to read is when so much is bunched onto a single sheet. You're trying to separate. You're just trying to separate everything, and it becomes an absolute pile of unreadable garbage. I do not like that. It makes it very difficult. So if you've got to add extra sheets just to manage and mitigate, to make it more human readable, to make it more sense, to have a more logical flow, do that. It's going to make your life a lot easier in the long run, especially when it comes down to troubleshooting. Because now you know, like this schematic sheet right here, when it's printed out, it only deals with the power supplies. This schematic sheet right here only deals with the core MC of the ESP32. So we're going to kind of refer to here. So limit switches are inputs. We know that. I mean, we're gonna either be reading out high or low. We might be able to make them configurable down the road. So let's try to do a little bit of preliminary plumbing before we end this video. We've got a couple minutes left. So because we want to kind of keep things ambiguous, we're just going to kind of come up with names and keep track of them down the road. Maybe write some product documentation for this as it gets developed. That way it's a bit easier. When we 3D print, design the enclosure, we'll figure out ways to label things to make them easier to use. All right, so what we're going to do is we're just going to throw in another port. So we know IO 34, 35, 36, and 39. Those are input only. That's all you can use them for. So we're just going to make them input only. Enable. All right. Multiple label input. Let's just no. I don't know what that's going to do. I don't want to mess with it. So we have enable limit underscore 1. Oh, okay. Underscore 2. All right. So what other input we want? So we have an enable. We have 2 limit switches. So we can set up like a third limit switch, or like a sensor switch. Let's say you want to throw this into a conveyor application just for giggles, and you want it to maybe have 3 stopping positions. So we'll call them limit switches, but actually they can be repurposed for other things depending on how you want to program it. Because it's going to be like an open platform, and it'll have example code, but you can go in and wipe it out and change it for whatever you really want, however you want to purpose it. So we're going to throw another limit switch in here, because let's say you have a conveyor application. You have like an input sensor, so it can detect when something's at the input, maybe something in the center. It can detect when it's at the center and maybe stop, trigger an output, and then another sensor to let it know it reached the edge of the conveyor. We could do other things. underscore 3. We're going to drop you right here. Plumb you together. So those are going to be limit switches. There's a lot of other things we can kind of plan and do plummeting on. Plummeting. I'm funny. Plumbing in. But we'll start that work. We'll start planning that stuff. Next video, tomorrow around 2, same time, it'll be the stream. We'll get it edited and uploaded to YouTube hopefully within a couple of days. There's still another video or two I still have to get uploaded anyway. I know a lot of YouTubers have release schedules. I'm not really worried about that because this is something educational, and I'm trying to help teach and get information out there. So I feel the more I can push out, the faster, the better. And it's the only thing I've got going right now as far as video project wise. Maybe down the road, if I expand my offerings, depending on feedback, comments, other people might want additional things, maybe additional designs, additional projects. Because I'm also learning to program the Click PLC. Who knows? Maybe we can do a video series on learning the Click PLC together. Who knows? We'll see what we can do. So right now we'll just quit here or ahead, and I'll get the video or the files pushed up to Git, and I'll see you guys tomorrow. Thanks for checking out, and have a great day.